we're back. This is the last unit that we're going to be doing this year. Kind of bummed, wish we were doing this in the classroom, but here we are, I guess. So what we're going to do today is talk about exponential functions, growth, and decay. So, if I have my main equation that I'm going to be using called an exponential function is f of x is equal to a times b raised to the x power. So let's label some stuff. F of x is just a fancy way of saying y. We know what that is. This little a is just a constant. It's what we're multiplying by. This b is our base. And this x is our exponent. So let's kind of talk about this b, our base. If our base, if our base is greater than 1, it is known as exponential growth. Exponential growth. So, for an example, if I have f of x is equal to 1.2x, I'm going to say that a is equal to 1, because really this is just 1 times 1.2. The b is whatever is being raised by the exponent. So b is 1.2, a is 1. So if I want, if on a graph, what's going to look like? It's going to start being little, but eventually just kind of shoot up. And this is kind of what's going on right now in the world. You know, with this coronavirus, it started off not so many cases, and then it keeps multiplying and multiplying by a steady constant. If your b value is not negative, we can't have negatives, but if it's between 0 and 1, so like a little fraction or a decimal, it is known as exponential decay. Think decay, kind of dying off. So, for an example, if I have f of x is equal to 10 times 0.6x, I know that a is this first thing, it's 10. B is whatever's being raised by the exponent, so b is 0.6. This base is between 0 and 1, so it has to be exponential decay. On a graph, what that looks like is I'm starting off and I'm decreasing really rapidly, but eventually it kind of goes off. So it kind of looks like the stuff we worked with rational functions when we were graphing them, how it was on opposite ends, but it's just one line here. So I got to wash this off real quick. Unfortunately, this whiteboard is kind of lame and does not let me erase neatly without Windex. I wish I had my smartboard. That would make things so much easier. Then we let it dry off. Hopefully it's dry enough. So, let's try a couple of examples. Number 1, I have y is equal to 2 raised to the x power, and we're going to state the domain and range. So the domain for all of these is always going to be all real numbers. The range is actually going to be, we're going to look and see, is anything being added or subtracted? If not, we're going to say that our range is going to be not all real numbers, but range is y, so we're going to say that y is greater than 0. We're never going to get a negative number. And the reason for that is I'll show you. I brought a graph. So what we're going to do is go into our calculators, go to your y equals, and you're going to go 2 raised to the x power. And I'm going to hit graph, and it keeps on going up and up and up. And if I go second graph, if you notice, the more negative we go with x, it never hits 0, but it gets really, really close. It's kind of like a boundary or an asymptote that we've learned. So we got a table full of points that we can plot down. So I have 0, 1. I have 2, 4. 4, 16. So it gets up really, really fast. And notice 2x, you can just plug in random numbers too. This little 2 is saying, hey, what we're multiplying by every time. We're multiplying by 2 every time. It means we're doubling. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. We are doubling every single time. And if you notice, we never hit 0, which is an asymptote. It is our horizontal asymptote. It's like that boundary. So we can say that this range, we can, if you want to, put down horizontal asymptote of y equals 0, and we know it's a boundary, so y has to be greater than 0. So that is number 1. Number 2. Is I have y equals 4 times 2 raised to x minus 1. So again, I'm going to go into my calculator, go to the y equals, and I have 4 times 2 raised to, and put parentheses in this, x minus 1. And we hit graph. Oh, dang it. Hit graph. And notice again, second graph. We get really, really close to 0. Never hit it though. So for domain and range, domain still is all real numbers. Range, if you're not sure, just look, nothing's being added or subtracted here. I can say there's a horizontal asymptote of y equals 0. So I know that this is going to be, y has to be greater than 0. So let's just take a look. If I plot points, I have negative 1, 1. I have 1, 4. 2, 8. And it gets really, really close to 0. So I'm going to draw a line in red showing there's a horizontal asymptote there. So it's approaching it, never crosses. If we notice, domain is all x values. So anything to the left, all real numbers. Anything to the right, all real numbers. But for my range, all my y values, I have all these values going up, but none going down. So it has to be greater than 0. last two graphs. So this has actually been growth. This has been growth as well, because our b value, our base, are both greater than 1. So if I look at number 3 here, I have y equals negative 5 over 2 raised to the x power. And just for fun, let's do plus 3. This is growth here, because I'm looking inside the parentheses. 5 halves is 2.5, which is bigger than 1. This is growth. And you may be thinking, hey, it's a negative. Well, the a value is negative. If I'm looking here, a is negative 1, b is 5 halves. So by rule, it's still growth. So I still want to find my domain and my range. Domain is all real numbers. And if I'm looking at my range, go into my calculator, and I'm not sure about my range for this one. So I'm going to go y equals that negative, put in parentheses 5 halves raised to the x power, and then plus 3. Should look something like that. If I graph, oops, if you notice, it's actually going to go down. Something like that. So it can actually go down, but what's important with everything we've done with growth, it can either start really slow and then go up, or it can start really slow but go down. Remember, if there's a negative in front, that's just a reflection. We're reflecting over the axis. So I'm going to go second graph, get some points. And we have 0, 2. And then some really funky ones. Some things that don't really matter. So just follow the shape of this. Doesn't need to be perfect. Should look something like this. And if you notice, it is never, ever, ever hitting the 3. Getting close, getting really, really close. But that's our horizontal asymptote. So, I'm just put HA for horizontal asymptote, is y equals 3. And for my range, I can kind of look at that and say, hey, is any value being bigger than 3? No, it's always below. So for my range, I'm going to say that y is less than 3. So for growth, we start slow, and then our rate of change gets really big. We either goes up or down. If we look at number 4, I have y equals 2 times 1/4 x. My b value is between 0 and 1. It's 0.25. So this is decay. And for this, we also need to state the domain and range. And the difference between growth and decay is growth starts off slow, gets big. Starts off slow, gets big, the rate of change. Well, with decay, our rate of change starts off really, really high and then eventually levels out. So let's take a look at this. Our domain, still going to be all real numbers. That's not changing at all. For a range, handy dandy calculator, I have 2 parentheses, 1 divided by 4, raised to the x power. I hit graph. And it makes a little L shape. And you notice we still makes a little L shape. Our rate of change is really, really high, then it gets low. Levels off. And it's still, our y value is greater than 0, because there's nothing being added or subtracted here at the very end. So I can just draw the asymptote first, or last, doesn't matter, get second graph, and get points. So one of the points is -1 and 8. And 0, 2. And then 1 and 0.0. So our rate of change starts off, hey, we're decreasing at a rapid rate, but then really quickly we wind up leveling out. This is decay. And that's all there is to it. I hope you guys have been safe with these times. I've been really bored. If you have any suggestions of like Netflix shows to watch, I'm so bored. I've been making puzzles. I mean, there's Baby Yoda, he's pretty cool, but I've been really, really bored. So send me suggestions of stuff to do.